Good morning. We're here for our second Geometry Regents review video, and I'm going to be looking in your review book at questions number 24, or page number 24, questions 35 and 36. So these two questions that I'm about to go over are questions that come up on pretty much every exam, and they're pretty easy as long as you know the process. So let's get right into it. Question 35 says quadrilateral math. Let me just change my pen size here. Quadrilateral math, and I've already plotted the points. M is -2, 4, so here is point M. A is 2, 1, and T is 2, -4. And we did go over a question like this on the last day of school, I think it was, -2, -1. I just want to make sure that you guys keep practicing this because, again, if we get a proof and you're graphing in your proof, then this is called a coordinate geometry proof. And for coordinate geometry proofs, you're using things like slope and lengths of lines to prove, like in this case, prove that MATH is a rhombus. Okay, so let's think about what we know about a rhombus. We know that a rhombus is a type of parallelogram, and a parallelogram has opposite sides that are parallel and congruent. And then to make our parallelogram into a rhombus, we give it all congruent sides. And so the first thing I'm going to do actually to show that it's a rhombus is show that it's a parallelogram first, and then show that it has congruent sides. So I need to find the slope of all four sides. So let's start with the slope of MH. And it's important that you keep your work organized. And so MH and AT I'm going to do together because I think those ones look parallel. And so since it's a completely vertical line, the slope of MH is actually undefined. So this is undefined, and AT is also undefined. Okay, so since they both have the same slope, I would say that MH is parallel to AT, and we usually use these three little dots, meaning therefore or in conclusion, and I know this because they have the same slope. Okay, and then I'm going to mark these parallel, and then I'm going to go ahead and do the other pair of sides. So MA and, oops, MA, sorry that's messy, and the slope of HT, I'm going to count. So when I count, I'm going to go rise over run, down and to the right. So to go down and to the right from M, I'm going 1, 2, 3, to the right, 1, 2, 3, 4. So this slope is -3/4. And then HT, I'm going to go 1, 2, 3, to the right, 1, 2, 3, 4. So this one is also -3/4. Okay, so now I can say that those two are also parallel. MA is parallel to HT, again, because they have the same slope. Okay, so hopefully we can see at this point that we have two pairs of opposite sides that are parallel. If I have two pairs of opposite sides that are parallel, then what I know is that that shape would be a parallelogram, like we have here near the top of the quadrilateral family tree. So I'm going to say this is a parallelogram. I'm not ready to say it's a rhombus yet. I'm going to say MATH is a parallelogram. Remember, parallelogram is the only one you can use a symbol for. Our reason is opposite sides are parallel. All right, so from there, now I need to show it's a rhombus. To show it's a rhombus, you need to show that a pair of consecutive sides have the same length. And so let's do the length of MH and the length of, let's say, HT. Okay, so that's this side I'm going to find the length of, and this side. So this one, MH, is easy because it's a vertical line. I can just count it. 1, 2, 3, 4, 5. The length of MH is just 5. You don't really need to show any work for that because you just counted it on your graph. But HT I'm going to need to show some work for. I'm going to do Pythagorean theorem. Let me just switch pen colors here. I'm going to say to find the length of HT, I'm going to do Pythagorean theorem with this right triangle right here, and I already counted it. It's 3 squared plus 4 squared equals c squared. If you remember your Pythagorean triples, then you would know that c is 5. If not, you would just work this out and you get c equals 5. So go ahead and do Pythagorean theorem there if you don't know your Pythagorean triples. So based on what we have, we see that MH is the same length as HT. So let's draw a conclusion. Hold on, my pen changed size again. So MH is congruent to HT because they have the same length. And therefore, MATH is a rhombus. MATH is a rhombus. That's what we know. Now we have to say why we know it. So we know it because it is a parallelogram, which we already said up here. It's a parallelogram with consecutive sides that are congruent. Here's our consecutive sides that are congruent. So MATH is a rhombus because it is a parallelogram. Oops, hold on. It is a parallelogram with consecutive sides congruent. Okay? We still have one more part, so this part is done. Now I'm going to prove that MATH is not a rectangle. So if we think about the family tree again, and we want to think about how we prove that something is a rectangle, if it were a rectangle, we would need it to have some right angles. And we know that for a shape to have right angles, they need to have negative reciprocal slopes. So I'm kind of all over the board here, but I need to just make a statement saying that since consecutive sides like MH and HT do not have negative reciprocal slopes, then there are no right angles. So I'm just going to say, therefore, well, actually, okay, MH is not perpendicular to HT. My reason is no negative reciprocal slopes. So in conclusion, MATH is not a rectangle. Consecutive sides are not perpendicular. Okay, sorry this is so messy, but hopefully you get the idea here. And really, I'm hoping that you guys get a question like this on your exam next Tuesday, because I think this is doable. I understand it's a lot to write, but it's really pretty straightforward and pretty easy, I think. So remember the process. If it helps, you can always draw this diagram. This diagram helps you remember what you need to do to get from parallelogram to rectangle or parallelogram to rhombus, and so on. One more thing you should remember about these shapes. In a rectangle, the diagonals are congruent. In a rhombus, the diagonals are perpendicular. You should know that, and it shows up a lot on multiple choice questions as well. Okay, so with that one done, let's go down and, let's go down, let me see if I can go down, and we're going to do question 36. So on question 36, it says, state the center coordinate and the radius length in simplest form for the circle. So we've done this question a lot, but it comes up on pretty much every exam, so I just want to double check and make sure you guys know it. If you want to pause this video and try this question now, and then play the video after you've finished, then you can double check your work and see if you got it right. So if I get started here, hopefully you did pause the video. If I get started here, what I want to do is I want to group my x's together, so my x terms, and then I'm going to group my y terms together, and I'm going to move the constant over to the other side. So when I do that, it's going to look like this. X squared minus 8x, and then I leave a space because I'm going to add another term there, and then plus y squared plus 6y, and then I'm going to leave a space, and then I'm going to move this 5 over, so subtract 5, so negative 5. Okay, so remember that a general form for the equation of a circle is x minus h squared plus y minus k squared equals r squared. I want my equation to look something like this when I'm done. And so really I'm going to try to factor these x terms into two equal factors so I can write it as a binomial squared. To do that, I need to come up with a number to put in where this blank is, which would be a perfect square. So you take that negative 8, which is in front of the x term, you divide by 2 and square it. When you square a negative, it always becomes positive. So negative 8 divided by 2 is negative 4, and then I'm squaring negative 4, which is 16. So I add 16 to the left. If you add something to the left, you also have to add it to the right. So let me just show you how this works out. I would have two binomials when I factor this as x and x, and the square root of 16 is 4, and 4 plus 4 gives me 8, and I want my 8 to be negative, so I make these both negative. Now think about it, negative 4 plus negative 4 is negative 8, and negative 4 times negative 4 is the 16 that we want up here. This is two equal binomials multiplied together, so we can express it like this. And so I've got this first part looking like the general form for the equation of a circle. Now I'm going to do it with the y terms. So with the y terms, again, I'm going to take that term 6, divide by 2 and square it. 6 divided by 2 is 3, squared is 9, so I'm going to say plus 9. If I add it to the left, I'm going to add it to the right. And now I'm going to factor and hopefully get two equal factors. Y and y. What two factors multiply to 9 and add to 6? It would be plus 3 and plus 3. And so since those are two equal factors, I can express it like this. The binomial squared. Okay, so on the right, I'm going to now add all these together. I have 16 plus 9, which is 25, minus 5, which is 20. Okay, so my center point, remember when you find the center, it's going to be the opposite of the signs that you see in the equation because of these minuses right here. So really to get this to say negative 4, I must have put in a positive 4. And to get this to say positive 3, I must have put in a negative 3. Your radius is the square root of this number, so the square root of 20. Now it says in simplest form, and so I'm going to have to simplify the square root of 20. To simplify, I think of the biggest perfect square that goes into 20, which is 4, goes in 5 times, and that is 2 radical 5. Okay, both of these questions show up on almost every exam. So if you watched these videos, now you can go back to page 24 in your review book and try to do them again and make sure you remember everything that we just talked about. So that's what I suggest you do tonight as part of your studying for your exam. And hopefully you are also working on those extra review questions or extra review exams at the end of your book for some extra credit for me so you can get your grade up. And we have review tomorrow after school. That's Wednesday from 3:15 to 4:45 in my room. Hope to see you there.